Hi everyone, welcome to our last video of 3 where we are going to factor 4-term polynomials. So let me zoom in real quick if you've been filling out this graphic organizer. This is a really good example of a problem where we would group. You'll see in the original problem, if you kind of hide everything else, this is a 4-term polynomial. And then I just showed some really basic steps of grouping. Now, if you can't just look at this and understand grouping, well, that's totally okay. I'm going to show you step by step in these notes how to do this. So hopefully you had some time to pause this and copy this down, but let's get into the notes. First, we're going to talk about the steps, how they look for a specific problem, and then we'll try to together. We're going to start obviously with a really basic one. We'll get into some harder ones. If we are given this 4-term polynomial right here, our first step is to write it in standard form. So that means I want my first term to be the highest exponent or the greatest, and then go down from there. So I've written this in standard form now. That's the wrong way. And we are going to follow along with the rest of our steps. The next one is to find the GCF of the first 2 terms. So I'm going to find the greatest common factor here, and then I'm also going to find the greatest common factor for these 2 terms. Now notice I did not factor out a GCF out of the entire polynomial because there isn't one other than the number 1. So always check, can I factor something out of all 4 of them? No? Then we move on to this step right here. So what I'm going to do is underneath write down what the GCF would be for each of these groups. So for the first group, my greatest common factor would be x squared. So I can factor an x squared out of both of these. So for these 2, it's x squared. For these 2, I can factor out a 5 out of both of these. So 5 is my greatest common factor here. Okay, the next step, I'm going to factor those out and make sure what's left in the 2 sets of parentheses is the same. I'll show you exactly what that means. So for the first one, I'm going to factor out x squared. And then what's left is an x minus 3. So that means when I factor out this 5, I want to make sure what's left in the parentheses is the same. So we're going to plus, and then I'm factoring out a 5. And then let's see what we get. If we divide this by 5, we get x, and if we divide this by 5, we get negative 3. Okay, good. My 2 parentheses are the same. That means they are like terms. This is a lot like if I had something written like this. Let's do maybe 4x plus 5x. If I had this, I could combine these because I have 4 of something and I have 5 of something. The same thing is true up here. I have x squared of something and I have 5 of something. So I'm going to combine like terms. So I'm going to add these exponents just like I would do, or these coefficients, just like I would do if I was adding these 2 terms together. These 2 added together would be 9x because I add the 4 and the 5. So I'm going to add these 2 terms right here. I'm going to do x squared plus 5. That's these 2 right here. And then times, and then the term that was the same, the like term. Okay, so this is the same thing as if I had like 4x plus 5x. It's going to equal 9x. That's how we look at grouping. Okay, so now I have completed the grouping steps. Then all you have to ask yourself is, can you still factor anything further? So I'm going to take a look at both of these factors and see if they're one of our special situations. Let's start with this one first. This is a binomial, but this x is to the first power, so we're not going to factor that any further. We're done here. Let's try this one. This is also a binomial, but this one has addition. So if you remember from the first video, the only time we can factor our 2-term addition is if they are a sum of cubes. These are not cubes, they're not perfect cubes, so we cannot factor this any further. So our final answer is x squared plus 5, that's one factor, and times x minus 3, that's the other. So that's your final answer. That is this polynomial completely factored. All right, so there's the steps drawn out for you guys. Let's go a little quicker now, but with some harder examples. If you were in my class, these are actually 2 from your CUDA homework. So if you follow these along, you'll have 2 of your homework problems done. All right, the first one. So I'm not going to go and show you guys each step from above. I'm just going to say them verbally. But the first thing I want to do is, again, like with any polynomial, see if I have a GCF for the entire polynomial. And I do. I can factor an x out of all of these terms. So I'm going to do that first. X times, and then I'm going to write this left over. So I've got x to the third plus 4x squared minus x, and then minus 4. So that's my first step. Now that I've done that, now I can use my grouping method to factor this 4-term polynomial inside. I'm just going to carry along this x every time I do a step. We're not going to do anything further with this guy. Okay, so for my first step for grouping, I'm going to find the GCF of these 2 terms and the GCF of these ones. So let me just write this x that's on the outside, and we'll try out our next step. So for here, the greatest common factor is x squared, and then what's left is x plus 4. And then here, well, you may say, the only thing I can factor out is a 1. But if I factor a 1 out of -4, I'll have -4 left. And I don't want -4 in parentheses. I want +4. Remember, I want those 2 parentheses to look the same. So I'm actually going to factor a -1 out of both of these terms. Notice they're both negative. So I'm going to factor out a -1, and then left over is x plus 4. So again, the reason I did that is because I looked ahead and knew that I wanted these 2 terms to be exactly the same. Okay, the next step for grouping, remember, is to combine like terms. So I'm going to combine their coefficients. This is x squared and this is -1. So that's going to be one of my factors. And the other one is the term, x plus 4. So again, this is like if I had 4x minus 1x, that would be 4 minus 1x, just like that. Okay, so we're done with grouping. Then you ask yourself, can I factor anything any further? So I'm not going to tell you right away. Pause the video and see if you can, or just wait a second. Can I factor anything else? And the answer is yes, I can factor this binomial right here. This is a difference of squares, and I have a special rule for factoring difference of squares. So again, I'm going to write my x factor. I've got my x plus 4. I actually don't want that. I'm going to wipe that out if I can find my whiteout. Okay, because I know I'm going to have more than just that. Let's factor this. So using our difference of squares, I know that this is going to factor to x plus 1 and x minus 1. And then I still have the x plus 4. Now I'm done factoring. Everything is factored completely, and this would be my final answer. You don't technically need these blue parentheses anymore because the x would be on the outside, but just know that you'd have 1, 2, 3, 4 factors here. And that's my final answer. All right, the next one, a little more work on this one. Again, ask yourself, can you factor out a GCF out of all of the terms? You cannot, so we are going to move forward and start our grouping. So I'm going to see, okay, my greatest common factor for my first 2 terms is a to the 4th. And then I've got a squared minus 1 left over. And then for these 2 terms, I can factor out a 16, but again, remind yourself, you want these parentheses to look the same. If I factor a 16 from this 16, I'll have a positive 1, but I want it to be negative. So I'm going to factor out a negative 16. Then I'll have an a squared, minus 1 left. That's a minus. Look at all the mistakes today. Okay, now we're at the step where we combine like terms. So remember, combine these in one parentheses, and then write your term that's the like term. Okay, ask yourself if you can factor any further. You absolutely can. These are both differences of squares. So let's do this one first. This is going to be a squared minus 4 and a squared plus 4. And then this one factored is going to be a minus 1 and a plus 1. Again, ask yourself, can anything be factored further? We actually have one more that we can factor, which is a difference of squares. So I'm going to factor this as a minus 2, a plus 2. I've got the a squared plus 4, and then a minus 1, a plus 1. We can't factor the a squared plus 4 for the same reason as I've mentioned in other videos, and it's because it's a sum of squares, not a difference, so we don't have a special rule for that one. Okay, so this is completely factored for number 7. Want to just point out something real quick. These two problems that I did after the steps were both already written in standard form. That's pretty typical. I'm usually not going to give you guys polynomials that are not written in standard form, but always just make sure before you get started. Thanks so much for watching, guys, and I'll see you in the next video.